This is problem 33 on page 587. We've got some information about this bacteria, and we want to know at what time, ultimately, there's going to be 20,000 of these little critters. At time 0, or at noon, there's 49. At 1 p.m., there's 294. And at 1:40, which is 40 minutes, is 2/3 of an hour. So 1 plus 2/3 is 5/3. At time t is equal to 5/3. We want to know how many there are. And then we want to turn it around and ask at what time there's 20,000. Our starting point, as in all of these exponential growth problems, is this differential equation right here. And k is a constant. P is going to be our population. So at time 0, our population is 49. The solution to this differential equation is my population is going to be my initial population times e to the kt power. And I know that my initial population over here is 49, so I plug that in and I get that. Now, we know that at 1 p.m. there's 294, so we can write down 294 is equal to 49 times e to the k times 1 power, or just k power. So we can solve this equation for k by first of all dividing through by 49. So we get that e to the k is equal to 294 over 49. We'll take the log of both sides, and the log of e to the k is just k, so I end up with k is equal to 294, or the log of 294 all over 49. And that thing, if we tap it out on our calculator, is approximately equal to 1.792 to 3 decimal places. Okay, so our solution to our differential equation, this right here, now becomes this. So we know that P is equal to 49 times e to the 1.792 times t. We can now answer this question here: at what time, or how many bacteria will we have at 1:40? We just plug in 5/3 into here. So at t is equal to 5/3, we get that p would be equal to 49 times e to the 1.792 times 5/3. And when we tap that out on our calculator, we get something like 971.5. So that's what goes in that slot there. Now we want to find at what time there's 20,000. So again, I go back to my differential equation here, or my solution to my differential equation, and this time I set p equal to 20,000. So let's write down 20,000 is equal to 49 times e to the 1.792 t power, and solve for t. Again, what we do is we divide through by 49 and take the log of both sides, and we'll get 1.792t is equal to the log of 20,000 over 49. And then divide through by t, and we get then, when we solve that, we get like t is equal to 3.35 hours. But 0.35 hours is equal to 0.35 times, there's 60 minutes in an hour, so I'm going to get 21 minutes. So our conclusion is this: at 3:21 p.m. there are 20,000 bacteria. And that is our conclusion.